far as data is concerned. Remember, today we are honored to have a professional who is a medical laboratory officer by background and so much knowledgeable on matters of information and data. Thank you to our members who are still coming in. We are starting shortly. And as we continue, we want to introduce our today's presenter. His name is Duncan Ongai, and he works with the county government of Kisumu. And also his current placement is in National Malaria Control Program. He's a master's holder in the field epidemiology and medical statistics. And therefore, he is so much knowledgeable on matters of data and information as far as laboratory medicine is concerned. So join me in welcoming our presenter. Mr. Duncan, are you able to hear me?
Yes, Arthur, I'm able to hear you well.
Yeah, thank you so much. And I think we have a good number, so you can proceed. Welcome.
So thank you so much, Arthur, for the opportunity and for the introduction. And let me take this opportunity to good afternoon, everyone, to greet those people who have actually who have already joined. Good afternoon, everyone. I hope you can hear me, and you can actually also see my screen, the screen that I've shared. So
yeah, for sure.
As Arthur has alluded, today I want to walk you through the utilization of laboratory data to inform action. So as he has said, we generate, as laboratory officers, we generate a lot of data, but many a times we don't analyze them so that we can inform action, or we can do something from that, so that we can deduce something from the data that we generate. So generally today, I'd like to take you through the descriptive analysis. So in terms of analysis of data, we've got two arms. So the first arm is the descriptive analysis, and the second one is the analytical analysis. So basically today I'll only take you through descriptive analysis. And somebody would be wondering, why are we dealing with the descriptive analysis? So descriptive analysis generally just maybe just like just introduction bit of it. Descriptive analysis just gives us the summary, just in the laboratory, just in a nutshell, in three components. So the three components that I'd like to basically talk about today is time, place, and person. So it's called TPP. So whereby time is the period that the event is actually occurring. Place is the study site or the study location, while the period is the period under which you are actually doing, or you are doing the study, or you are doing the data collection. So why descriptive? So descriptive is actually the easiest part, being that it does what we call, it uses what we call measures of central tendency. So what are the measures of central tendency? So measures of central tendency are mean, median, mode, and I'll also rope in measures of dispersion. So I think from our school, our days in the professions, we've heard of mean, which is usually just the sum of the data that you'd actually want to analyze. Then the mode is now the frequent value that is in your data set, while median is now the middle. So measures of dispersion we also have. The measures of dispersion we've got two, that is interquartile range and standard deviation. So these ones are usually used in descriptive analysis. So somebody would be wondering, why are we using the descriptive analysis? So descriptive analysis, we usually use them just to analyze what we call continuous variables. So the continuous variables are usually used to analyze what we call the measures of central tendency and dispersion. So that is the topic that I'd like us to talk about today. That one was just a little bit of the introduction of the topic, of our today's topic. So I want to, are my slides moving?
Your slides are not moving.
My slides are not moving.
Yes, kindly.
Let me reshare again.
Okay, kindly. As we are waiting for him to share, I think he's trying to share again the slide so that they are able to move.
What about now?
Yes, can you move to the next slide so that we're sure it's moving? Able to move to yes, it's moving. Well, good.
Moving now.
Yes, just continue.
Sorry for that interruption. So I've got objectives that we'll actually use for today in our today's presentation. So some of the objectives, I have got 6 objectives that we shall actually be using today. So one of the objectives is to systematically collect, analyze, interpret, and apply laboratory data to inform clinical decision making and operational improvement. So generally, this one just in a nutshell just gives us what data analysis or data collection entails. So for you to analyze data, you've got to collect it. And for you, the data that you've analyzed, you've got to interpret it, and you have to come up with a clinical decision, or what are the results of what you've actually analyzed. You've got to interpret it in terms of the results. So number 2 is about to transform the raw data. Raw data, those are now the records that we've got in our laboratory registers. So our laboratory register here, I'll be using MOH 240 and MOH 545, which is now the weekly surveillance data. I'll be referring for those ones. So number 3 is to identify them and monitor the trends. So in the laboratory, we can actually use line graphs to monitor our trends, patterns, and outliers, and seasonal variations in laboratory data utilization and results to enhance quality assurance and planning. So in terms of trends, we can use line graphs. We can also use pie charts for our data representation. We can use graphs, and we can also use tables. So I'll take you through the rule of thumbs while using all those ones, while using line graph, while using tables, while using graphs, and while using the tables and the pie charts in the preceding analysis, in the preceding presentation. So the other one is to validate and define population, specific laboratory reference ranges to improve diagnostic accuracy. So this one is mostly during validation processes, when you want to do validation processes so that you define the population. Then the 5th point is about to support continuous quality improvement. This one is just CQIs in our laboratories, because after doing the analysis, it would actually tell you where are the gaps, where should we put more strength, and where can we actually work on so that we get the right information in place. Then the lastly is to facilitate research by providing descriptive data for clinical study design, hypothesis generation, and real-time world evidence development. So in terms of the research, I talked about two. That is the analytical bit of it, and the descriptive that I'd actually want to walk you through today. So we've got the design. So in the descriptive bit of it, we don't usually generate hypotheses. There's no development of a hypothesis in descriptive analysis. While in an analytical analysis, we've got you've got to come up with the hypothesis. That is the null and alternative hypothesis. So in analytical also, you've got to come up with, it's also called inferential statistics, whereby what is the inferential statistics? So inferential statistic, you've got to come up with what we call the confidence intervals and the p-values. So you've got to analyze, and you come up with interpretation of the p-values. So p-values are usually also set in terms of depending on the data set that one has. So we've got the p-values of 0.05, 0.02, and 0.01. These ones, they usually correspond to the confidence interval. Like 0.05 is 95% confidence interval, while 0.02 is 98% confidence interval, while 0.01 is 99% confidence interval. So why would somebody maybe talk about 99% interval? So this one, you've only got 1% error rate. You will only error with only 1%. While at 95%, you've got an error rate of 5%. Then at 98, you've got to error with almost 2%. So closer to 100%, if you've got a confidence interval of 99%, this means that you'll have a very large sample size, and the precision of the sample size will actually be below as compared to the normally used 0.05, which is 95% confidence interval. 95% confidence interval, and that is what is usually used most of the time in most of the studies. So you are able to do that, and you are able to deduce the odds ratios. Analytical studies, we use the odds ratio, while in descriptive analysis, we always use risk ratios. So in terms of the, this one is just but the introduction. So in the introduction, I'll take you through the data collection, just the processes. So this one is the systematic process of collecting, analyzing, and interpreting and applying data to make informed decisions on improvements and laboratory operations of the patient care. What are the core purposes? Is to transform the raw laboratory information into actionable insights that guide clinical decisions, operational improvements, and strategic planning. Then the scope is it encompasses all aspects of using laboratory data from individual patient results and population health trends and operation metrics. So what are the sources of the laboratory data? So we've got sources of laboratory data is categorized into 6. So the first is from electronic health records, that is EHRS, systems that store patients' data, results, and clinical information within the healthcare systems. So we've got different systems in place, that is in the laboratory. Then we've got LIS. So this one we know, laboratory information system of specialized tests, specialized software used in laboratory to manage test orders, data capture, and reporting. Then we've got research databases, aggregated data, databases collected from clinical studies, trials, and research projects. We've also got paper-based. Majority of our places are yet to be paperless or are yet to digitalize their systems, so they still have what paper-based. Though paper-based has got so many issues and so many when it comes to data quality assessment, in terms of completeness, data accuracy, and timeliness. It has a lot of issues. Then we've got real-world data sources, laboratory results collected outside clinical trials used for broader public health and research purposes. This one is basically the research setups. Then public health records, data related to disease surveillance and outbreak investigation. So generally public health records. So we've got data that are very much important in the laboratory. And mostly the data that we always collect, the data that are usually collected in weekly basis and monthly basis. So some of the data that we collect on weekly basis are now the malaria data. We've got the typhoid fever. We've also got dysentery. These are usually data that usually captured in MOH 505. So I'd like to challenge colleagues that we always collect or we always send this data from MOH 505. That is from IDSR MOH 505 weekly reporting tool. We always send the malaria and the typhoid fever cases to the public health. Have you ever wondered or have you ever monitored even the trends of the data that you usually send to the sub-county or just to the facility PHO so that they can be keyed in KHIS? Do we have, like now the profession, the laboratory officers, do we have the KHIS rights? Are we able to do quality data review for our data before they are keyed in the KHIS? So I think that one we need to come up with that, and we need to monitor the trends so that we can detect the outbreaks, and we can also do the surveillance just using the more normal, the simple Microsoft Excel. Just a simple Microsoft Excel. We're able to come up with the graphs, and we are able to come up with pie charts. We are able to come up with the line graphs, and we are able to monitor the trends over time of the tests that we do. Generally, the diseases that are in the radar of the WHO. So what are some of the diseases that are in the radar of the WHO? Maybe those of us who are actually doing microbiology. So we've got the 5 diseases that are in the radar of the WHO. So we've got the proteas, we've got Acinetobacter baumannii, we've got Kleb pneumo, we've also got Escherichia coli and proteas. So all those ones, we need to capture those kind of the trends of those kind of organisms. Then when it comes to malaria, very much important, we've got also to monitor the trends of the malaria in most of our laboratories so that you are able to capture in whether there's what we call upsurges. So the upsurges can actually be monitored using 2 components. So we've got 2 components, that is the alert and action thresholds. So these alert and action thresholds, how are they generated in the laboratory? They're generated from the mean plus 1.5 standard deviation in our system. That is now what is used in the KHIS. So if you've got the alert thresholds, so this one just alerts you that you've got an upsurge of malaria that you actually need to work on it. But if you get what we call the action threshold, so this one is something that needs to be responded to. And this one is mostly in outbreak setups. In cases of cholera also, I'm basically talking about IDSR, that is now MOH 545, cholera causes that we monitor in the laboratory. Only one case constitutes an outbreak. I think we are all aware of that. That one case of a cholera case constitutes to an outbreak. Then we've also got bacillus, we've got anthrax. Just a case of anthrax constitutes an outbreak. Even one case of chikungunya, just that constitutes an outbreak. Right now, we are struggling with the mpox. Just one case of mpox also constitutes an outbreak. So we've got a lot of things. We've even got TB. We've got HIV data that we need to analyze so that we deduce and we interpret them so that we can actually inform actions in our area. So this slide is basically about the components of how do we go about our data collection. And today I want us to use Microsoft Excel, which actually is now the easiest that we'll actually use now in the analysis. We'll not use the other softwares like the Stata. The Stata, the latest version, I think, is version 24, that can actually give you both multivariate and univariate logistic regression and linear regression in your analysis. We also got AP Info version 7.0. This one is also very easy. We can also use that one in our analysis. We can also use SPSS. SPSS is a social package for social scientists. The latest one is version 26, which is embedded with artificial intelligence and can actually help you to do what we call visualization. So the best of all the components of all the tools is now the R. The R software is the best. So R software has got the R Studio, it has R console, and it has the R component, and the most importantly, it has what we call the G plot. The G plot is able to plot for you all the graphs, because by the time you are doing the analysis, you've got to come up with the study location. So the study location, if you've got the GG plot, you are able to draw the map of that location. If you've downloaded the shape files, then you are able to draw. You can also use another software called QGIS. QGIS can also help you to draw the maps in your various facilities. So we've got data processing, we've got data collection, data processing, which is basically cleaning. So the data that you've collected, let's say we are doing data for malaria, and we've collected the data, and we've got several variables for the malaria, like we've got age, we've got sex, we've got test results, we've got the results that we've got. We've got any other, we've got weight, we've got temperature, all those variables that you've got. So you've got to feed them in your the software that you are using. Either is Microsoft Excel, is Stata, SPSS, is R, or SQL, whichever that you're using, or AP Info. You feed them, then you do what we call data cleaning. You clean the data for the blanks or any errors that you could have actually made during the data data collection. So then after that, you now move to the data analysis. So in the data analysis, you can actually use the statistical or analytical methods that I've talked about. But the simple one is just after you've done the data cleaning, so you just feed your data in Excel, and whether you can actually use the Excel, you just feed it and use the pivot tables, and you draw your graphs. You come up with the tables, you come up with your graphs, and you come up with the pie charts. So then we've got the second last is about the data interpretation. How do we interpret? For descriptive data analysis is very easy because it's something that is very simple. We shall actually see in the coming slides how we can actually do the findings, how we can interpret the findings. So this particular time, let me take you to the rule of thumb. The rule of thumb in the analysis while you are using measures of central tendency. Measures of central tendency and dispersion are talked about mean, median, mode, interquartile range, which is usually the maximum minus the minimum range, which is then you get the interquartile range, and standard deviation. So if your mean is twice if you multiply your mean and it gives you, it doubles the standard deviation. In this case, you don't interpret using mean or standard deviation. You use median. So you'll use median and interquartile range. If your mean is times 2 the standard deviation, and if your mean is not times 2 of the standard deviation, then you'll use mean and the standard deviation. I think we are clear on that. So that is now the rule of thumb while using measures of central tendency and measures of the dispersion. Then we've got data application, using insights to make decisions and implement improvements. So this one is just for decision making. Then the data communication. So data communication generally is about visualization. I talked about the R Studio or the R as a software. If you've got the R and you are very conversant with the R commands, most of these statistical softwares, you've got to know the commands. You've got to know the commands. You've got to learn the commands. If you can't learn the commands, then you are lost. You will not comprehend. So in R Studio, R as a software, Stata as a software, SQL as a software, SPSS as a software, they've got visualization, and you can actually visualize what you need. Whether it's a line graph, whether it's what, you can actually visualize in those softwares. So continuation of descriptive analysis. So we've got the statistical methods. It summarizes, organizes, and design main characteristics of laboratory data without making inferences about larger population. So if you underline, if you get this word called inference. So inference talks about associations. So in descriptive analysis, we don't have inferences. Inferential diagnosis, we only have in analytical analysis. So analytical analysis, we've got two types of analytical analysis. So we have observational wing of it, and we've also got experimental wing of it as the inferentials. So in the inferential, in the experimental bit of it, we've got now the randomized clinical trials. While in the observational, we've got what we call case control, and we also got what we call the cohort studies. So case control studies. So case control studies is whereby you've already got what we call, there's already an outcome. You are looking for the cause. And you've got to compare the two. You've got to have a case and a control. That is why it's called a case control studies. And in this, you use the odds ratio to deduce, to do the research bit of it. While in a cohort study, you've got somebody who has been exposed and you're now looking for the outcome. So there's an exposure, you're looking for the outcome. Like you've got somebody who's been smoking, cigarettes, and you want to relate it to lung cancer. So is there association between lung cancer and cigarette smoking? So that is what is basically, there's an outcome, you are looking for there's an outcome, then you're looking for the cause. Then we've got the primary function, which provides what happened during the data presenting meaningful ways through measures of central tendency, variability, distribution patterns. Then foundation role forms a baseline of understanding necessary for all other types of data analysis and decision making. So I think we are still together. This one is why is clinical and public health action important to us as laboratorians? Why is it important to us? So as laboratory data that we generate, through descriptive analysis, it informs actions like, it improves diagnostic decision-making by identifying trends, variations in test results. So this one I've talked about, maybe you actually want to analyze, or you'd actually want to do trend analysis from 2021 to 2026. How are the trends of the malaria in my laboratory or in my facilities? How are the trends? So in this case, we'll use the line graphs, or we can use the histograms. We can use even the tables, but the tables are not good. We can use graphs on the same, so that, but the best one is using a line graph, so that the line graph will actually show you what is the trend. What is the trend? How has the trend been all along? So this one I'd said, we are using tables, graphs, and line graphs on these identify the trends and variation in the test results. So supporting the public health surveillance, which is very important, monitoring the disease patterns in the population, which is also very important because we need to do the surveillance. So that is why it's called integrated disease surveillance and response. That is the IDSR with the kind of diseases that I've talked about, which we always monitor monthly and weekly in our laboratory. So we also have enhancing laboratory efficiency and productivity through quality assurance metrics and operation indicators. So from this, we are able to deduce, we are able to come up with the quality, the efficiency, and the matrix in terms of operation indicators that we've got in the laboratory. So it depends with the kind of the indicators that as a lab you are monitoring. So if you're monitoring the TAT, how is the trend of the TAT in your laboratory? Are you able to calculate the TAT of your laboratory? Are you able to come up with the trend of the TAT in your laboratory, so that the trend would actually help you to put more efforts, or maybe just to initiate an action? What could have actually happened if you've got outliers in your trend? What could have actually happened to these, so that you get to fix the outliers? So also guiding policymakers and health programs with evidence-based insights for planning and resource allocation. So this one basically goes to the workload that we've got in our laboratories. So the kind of workload, if you need capacity building, what are the gaps? Do you need more staffs to be deployed to your facility because of the workload? The workload is too much that they are not able to handle. So that one is basically the policy making. So applications, monitoring, this one is just but an example. In one of the labs, they were monitoring culture media, that is the blood culture, and they found that the clinicians used to collect 2.3 mils initially, but after the analysis, they collected 8.6. That is after the intervention, and this one led to improved detection of pathogens and good quality patient outcome. In a local public health laboratories, they also use descriptive data, but not only for patient, but for community disease control and emergency responses, mostly outbreak responses in most of the laboratory labs. Then descriptive data can also be used. The data analytics can also be combined with benchmarking to measure the performance against standards, helping the lab to optimize processes continuously. So this one is a continuous process, quality monitoring and through trend observation. So still on the analysis, majority of them I talked about, that is the statistical methods. I talked about that. And I'm so much concerned that each and every graph that you come up with, each and every pie chart, any table that you've got you come up with. So the rule of thumb, again, when coming up with a table. So a table you are supposed to label a table on top of the table. So the description that I've talked about, the TPP, time, place, and person of a table. So like this one is a table showing distribution of malaria parasite in Nairobi County, March 2025. So the time of place is captured, the time of person is captured, which is malaria. The place is also captured as Nairobi. So you've got to capture all those ones. So in a table, we labeled on top, while in a graph, we label as figures and we label it down and we italicize. So the figures are supposed to be italicized below each and every graph. So that is the rule of thumb while you're doing tables and using the graphs. So inside the graph again, you are not supposed to have what we call the grid lines. So you left click and you remove the grid lines. The grid lines are not supposed to appear in a table. You are supposed to have the data tables. Then you can also increase the size of your histograms or your graphs. You are supposed to increase so that they become very visible. So we've got the Y and X axis. So the Y axis and X axis you are supposed to label well. I'll show you in the preceding slides. So always remember that while labeling our tables and our graphs, and graphs have said we are labeling them in terms of figures. So figure 1 showing distribution of this and this and this and this and this place in time, place, and person. Then I've also talked about the rule of thumb while using measures of central tendency and dispersion for what we call continuous variables. We've got categorical variables and continuous variables. So categorical variables, we use what we call proportions and frequencies. Proportions are just percentiles, while frequencies are just the same computation. So in terms of central measures of central tendency, we'll use graphs and charts. We'll use measures of central tendency, that is mean, median, mode, the interquartile range of that. Just an example. So of the 279 samples that were gotten, the median age was this with interquartile range of this, or the mean was this with standard deviation of this. So that is now how you deduce, how you come up with your results. So having that is done in terms of time, place, and person. The most age group affected, place, study location of study site, or the location of, we said we can use ggplot or we can use QGIS to come up with the map of our place. Then we've also got time, that is the occurrence. This one is done in terms of years or months. So these ones I've talked about mean, median, mode, standard deviation. We've got range, interquartile range, and coefficient of variation. This one is basically in the standard deviation. So still analysis, we've got distribution analysis, the frequency distribution. This one is used in using categorical variables, and this one is in analytical studies. We've got histograms. Histograms, we use them in descriptive analysis. Skewedness. How would one tell that my data is skewed? So if your data is skewed, that means it doesn't hold at the center. So we've got what we call outliers. So if it doesn't hold at the center, then what you need to come up with, well, that is why I said you are not using mean and standard deviation if the mean is twice the standard deviation. So in this case, use the median and interquartile range. So that one will actually give you the center of your data. Measures of central tendency, measures the center. Then in terms of kurtosis, this is how peak or how flat your distribution appears. Your histograms or your graphs, how peak are they and how flat are they? So I also talked about in terms of time, there's what we call, we can use to represent time in here that I talked about. So if you can use what we call the epidemiological curve. So this one is, the epidemiological curve is usually used in most of the outbreaks. So it gives you how the peak was and how distributed the cases are. I'll show you, I've got one of the EPI curve, epidemiological curve on monitoring. So this one can actually be done in terms of, you can do it in terms of days, you can do it in terms of epidemiological weeks, you can also do it in terms of months. So this one will tell you, was your infection from a common source? Was it from a pointed source? Was it from a propagated source? Or is it a common continuous source? That is in terms of time. In outbreak investigations, we always use what we call an EPI curve. I'll show you one of the EPI curves in my presentation. So pattern recognition, we also got the trend analysis, which is the change in time. Then the seasonality patterns, which is very much which is very much important. We've got to come up in our various facilities, we need to come up with the seasonality patterns, and we've got to manage why seasonality patterns. So let me give an example with malaria. So in malaria also usually has got seasonality. And malaria usually what does that after every short and long rains, so we always anticipate malaria upsurges. So you've got to come up with a seasonality patterns so that you monitor. After the short rains, how are the peaks? After long rains, how are the peaks of the malaria? So that is under the seasonality patterns, which is very much important. So that why are we monitoring the seasonality patterns? So that we come up with the upsurges, which is mean plus 1.5 standard deviation or under action and alert thresholds in our KHIS data. Then under the outlier detection, identification of unusual and extreme values. So under outliers, in statistics, is usually recommended that if you've got an outliers, you can actually use what we call matching. You can also do stratification. Matching is usually done in case control studies. You can match a ratio of 1 to 2. You can also use randomization or stratification so that you do away with outliers. So in terms of application, again, this one is just para continuation. It monitors control sample results for analytical performance. This one is mostly in our chemistries. It also tracks precision and accuracy, which is very much important in the laboratory. You've got to be, in terms of precision, are your data points and your samples accurate to the point? Are you able to produce the same results over time? Then you identify the instrument drift for the systematic errors. So the systematic errors during maybe you've done a control and it hasn't passed, you've got to troubleshoot and you come up with what could actually be the cause of that. Then evaluate method performance and stability. You've got to evaluate your system. How is it? So the system in system evaluation, which is very much important, you have to come up with what we call the predictive value negative and predictive value positive in the system analysis. What are the attributes of my system? What are the attributes of my system? What are my users saying in terms of the system? But the most important thing is the sensitivity, the predictive value positive, and the specificity of our test performance stability. Then clinical applications, you've got to establish population-specific reference ranges. I think this one we always do. We also need to monitor patient population health trends. We've talked about this, which is very much important. We've got to monitor the trends. We support clinical decision making with baseline data. Then we track treatment response patterns, which is very much important. What are the outcomes, the treatment outcomes? Are we making any strengths or are we losing it? Are we on track on the same? Then from that, the treatment, this one is mostly done in our care and treatment. That is for the patients who are on care. How are the treatment responses? Even in our culture and sensitivity, you can also monitor the treatment patterns. So part 2 is about operational applications. You analyze the test volume patterns for the resource planning, monitor turnaround time. I talked about that. Evaluate specimen rejection rates. Rejection rates from the TAT, I think that one is something that is doable. We can do that. Then we can assess the staff productivity and workload distribution, which of course, that one from the trend analysis from the workload, then that is can actually inform action on how we can how we can use our workload maybe to bargain for additional staffs in our laboratory. So under quality improvements, we establish the baseline, which is very important. You've got to do the baseline so that by the time you are doing midline and endline assessment, you've got the baseline, midline, and endline assessment. You can actually compare. Was there any change during baseline? And what is it in the midline? And what is it at the exit or the end line? And monitor the progress towards quality goals so that you achieve your goals. Identify areas needing interventions. Then document improvements, outcomes. So document improvement per se has got a lot of problem. I talked about majority of our facilities that are still using paper-based. So many a times you should do what we call data quality audit. That is the DQA. Are we able? Let me give an example. Maybe you'll say I'm biased, but let me just give an example with malaria. So malaria, how can we do the data quality audit as laboratory or as laboratory staffs? Just in your facility, how can you do the data quality audit? So the data quality audit, we've got what we call, we've got the source documents and we've got the source documents, the three of them. So which are now the MOH tools that I'm basically talking about. We would want to do the data quality audit or data quality assessment in our facility. So number one, we've got MOH 204 A and B, which are now the outpatient registers. We've got MOH 705 A and B, which are the monthly summary, OPD monthly summary. Then we've got MOH 240B, that is now the laboratory register. So our source register here is 204 A and B. So from the 204 A and B, you are supposed to get what we call the suspected cases, confirmed cases, and tested cases. Suspected, somebody who is suspected is supposed to be tested for him to be confirmed. So you will go get those, depending on the case definition of the disease that is under your radar. So in this case, we've got malaria. So your suspected case would be somebody who's got joint pains, so a patient who walks in and presents with headache, joint pains, and fever, and any other. We can now talk of myalgia and the rest. So that will be your a suspected case. While your tested case is somebody who is tested with microscopy or MRDT. That is confirmed case. Is confirmed with microscopy or MRDT. Then that is tested case. then confirmed is confirmed with that the malaria is confirmed with the microscopy or MRDT. So we'd want to look at these three registers, the registers that are in the OPD and the register that we've got in the laboratory. Are they having what we call concordance rate? So in this case, we are basically talking about concurrence between across the data sources. So we are talking about concordance of data in terms of what we call completeness. Are the data complete? Are the data accurate? Are the data accurate? In terms of timeliness, how are they? And in terms of reporting, how are they? Is there any are these data talking to themselves? Are they speaking to themselves? Like if you talk about 204 and 705, are they on the same level? Are there concordance in across the three registers? If there is no concordance, then you've got to come up with an action. You've got to do what we call data quality assessment, so that you fish out what could have actually been the root cause. And in this case, you're supposed to come up with what we call verification factor. Verification factor, you're supposed to calculate our KHIS and the source document and laboratory, the three. You divide and you come up with what we call verification factor. Any verification factor that is less than 0.9 shows what we call, that is less than 90%, shows what we call over-reporting, while any figure that is over 1.1 shows what we call under-reporting. So that one is something that we can always do in our laboratory, just to ascertain from our KHIS what we record in KHIS, what we record in the lab, what we could record in the OPD, and we come up with that. So I think these ones are just key benefits. We get error detection, quality assurance, continuous monitoring of laboratory performance, resource planning, workflow, organizations, and evidence. In patient care, the reference range validation, clinical decision support, population health insights, treatment monitoring, and in management, we've got performance metrics, objective measures of laboratory effectiveness, strategic planning, and regulatory compliance, meeting accreditation and quality standard, which is very key. That is ISO 15189 2022 version. So implementation steps, I've got 4. I'll rush very fast to that. The first phase is you identify the key metrics and data sources. You establish data collection protocols, of which I don't know whether we've got protocols in our places, but in the national offices, we always develop concept notes and protocols before you undertake any data audit. So you set up automated reporting system, train staff on basic statistical concepts. 2 is analysis. You collect descriptive, create visual, establish normal ranges, and develop trending. 3, you do action on the findings. 4 is integration. Analysis, you embed your analysis with the workflows, develop dashboards, like the malaria dashboards that we have in the KHIS. You are able to visualize the KHIS, and you are able to see what is being reported. So implementation, I've talked about the line charts, I've talked about the multi-graphs, the sunken diagrams. We've got the parallel coordinate plots, and we've also got the dashboards. So how I wish we could also have maybe a chance of having, we can navigate through, we can navigate and triangulate. We can navigate and triangulate between KHIS and the NASCOP dashboards, so that we can monitor what we generate in the laboratory. How I wish we could be allocated, or those of us who've got the KHIS rights, you are able to monitor the dashboards. So that in the dashboards, we've got the charts, graphs, anything that you need. So the practical for visualization and using the trends. we've got the time series, visualization trend. We have the heat maps, interactive dashboards I talked about. So these are, we have the LIS, that is laboratory information integration, that leverage on the lab information capability, automated analysis. We've got the statistical softwares that I've talked about, which is very important. The first thing that is very much important and can actually be used by anybody is Excel, whether it is advanced or just the normal Excel. We've got the Stata, the latest version is 24. We've got R, which has got R Studio, R Environment, R Console, and the R commands, and the ggplots. You are able to plot everything that you need. We've got a social package for social scientists, that is the SPSS version 26, which is embedded with the AI. You are able to do anything that you need. Then we've got AP Info version. The latest one is version 7. You can also use that to do the visualization. Then we've got the dashboard review. I've talked about that, the KHIS and the NASCOP. Then we've got data export methods. So the data can, you can actually import data as CSV or Excel. So it depending on what you want. When you're using Excel, you'll use XL, but when using Word or maybe you want to export the data in AP Info, then you'll use CSV. So this one depends on the version that you want. Is it 1997 to 2000? That is depending on the kind of the software that you're basically using. But the rule of thumb is that we can always use this. We can always start small so that we cascade down, so that we get to know this kind of the softwares that we have, so that we analyze our data. We can always start small as we get to the data. So I want to take you through what I was basically talking about. So number one, if you look at the chart from what is showed, that is the line graph. So I talked about the line graph. So the line graph shows, it shows you the progress. So these are in terms of years. We've got x-axis and we've got the y-axis, and we've got now the trend. You are able to monitor this. You are able to monitor that. Then the second one is a graph. You can actually see the graph. It has got the proportion cases of malaria and the malaria species. So we've got the Plasmodium vivax, Plasmodium falciparum at 78. We've got Plasmodium vivax at 10, mixed infection 8, others unspecified 2 and 4. So these ones are the figures that I was talking about, the 78, 10, 8, if you can see them, and 4. These are the data labels that you are supposed to visualize so that we can actually see them. Then in terms of your y-axis, you are also supposed to be, it's supposed to be 100. Then you are supposed to label them well in terms of what your readers, somebody should actually see just in a nutshell what you are trying to present to them. So on this one is also age group in terms of years. We've got age group 0 to 2, 3 to 4, 5 to 14, 15 to 44, and over 45 years, which is very much important. That is in terms of age group. Then down, we got this one is terms of place, and it has also cases. So the rule of thumb in terms of place, again, if you've got figures, you are supposed to do it in a descending manner. Kindly do it in a descending manner. Start with the 27, 23, up to the last one. That is the rule while using the graphs. Always start with the highest going down. Then you can actually see between the bars, there's nothing. There's no any grade. So you right click and you remove the grade lines. You right click and you get the data labels. You right click and you extend or you elongate the graphs to be in a reasonable size. So on continuation, this one is also the PT performance. You can actually see we've got the data labels, they've been visualized well. We've got the data labels. We don't have any grid lines. This one is good to go. Then in terms of this is what I wanted us to see. This is a table. So the table has got frequency and it has the species. So the rule of thumb while using a table is that anything that is, you're supposed to have your denominator, not the numerator. So the denominator is N44. So those were the samples that were analyzed, N44. So always have your denominator in place. Then your figures, your numericals, they're called the numericals. So always arrange them in one line. Then you don't put a lot of spaces in between. Try and squeeze the period, and you use the double lines. So you just go on top, and you go to boundaries, and you put the two lines in between. You can actually see those ones. So that is still that is the rule of thumb while using the tables. So this one is we were trying to calculate the verification factor in malaria weeks. We have the confirmed malaria, the confirmed virus, confirmed with the different sources, MOH545, KHIS, the tools that I talked about, and this one is the verification factor. So that is also another one. That is also another table. And I'd said as a rule of thumb that in tables we name them on top, while figures which are now graphs, we label them below, and it's supposed to be in terms of TPP, time, place, and person. So in your right on the right, a figure on the right shows an epicurve. That is what I talked about. So this one is done in terms of epidemiological weeks. So even our laboratory, the data that we always generate weekly basis in our laboratory is done also in terms of weeks. So we've got week 1 up to 52nd week, 52. Week 52 is now the last week. So a week usually runs from Monday to Sunday. Then you are supposed to compile the data within Tuesday, and the data is sent on Wednesday. Every Wednesday, the data is sent, but the week runs from Monday to Friday. That is week 1 in January up to 52nd week. So from this AP week, you can actually see this one was a continuous common source. So I talked about 3 cases when you talk about when you want to talk about place, when we want to use what we call the epicurve. So epicurve, we've got 3 types of epicurves if you want to use an epicurve. We have a common source, we have a continuous common source, and propagated source. So this one started on week 14, and it just moved. The peak was in week 27, as you can see. From week 27, week 27 recorded the highest number of cases. Then there was a decline showing that the outbreak had already been managed. So up to week 29, up to week 31st, shows a decline of cases, showing that the outbreak had already been contained. But from week 14 up to week 27, there's a upward increase of cases. So that one can actually help you. So these ones are stuck. So the in between, you can actually see there are so many cases in between. But in a propagated cases, you'll see there are spaces in between. Like on first, you got 2 cases, then another, you got another case 20th. So in between, there's a lot of space. So this one is also another table, which is also very much important, shows the variable category, a frequency, and we also got proportion. So proportion is in terms of percentages. Then the rule of thumb that I was talked about is now your denominator, which is very important. This one was N179. So these ones were the cases. Then you use now the double lines. You just go to the borders and you click on it, and it will actually give you the double lines. So that is in terms of proper presentation and proper presentation of graphs and tables. So these ones, you can actually use them to develop from our lab. We can come up with abstracts, we can come up with manuscripts, and we can come up with so many publications in terms of this. And these ones, we can actually send them to various conferences, so that you just go and defend your data. So long as you've done just the normal descriptive analysis, time, place, and person, and you do your results well, you do your conclusion well, you've got your methodology well, and you got your introduction well, you can do a manuscript, and you can come up with a proper manuscript, and you publish, so that people can also Google you. And if you are Google, so somebody Google you, you are among the scholars. So this one, this table also shows, this one was just age group categories. If you want to analyze your data, and in terms of age groups, it's better you clump it like this in terms of age group, and I've got male and female. So you can actually see age group 15 to 24 was the most affected between male and female. And this one was a study that we did in Wajir County. So this one, it doesn't align with the majority of the findings, and whereby you find majority of findings that under 5 are usually, that is in lake endemic regions, are the most usually affected by malaria. But in Wajir, it was 15 to 24, followed by 15, followed by 23 to 34, then 5 to 14, then under 5 were the least affected. So just to wrap it up, I'll just wrap it up because of time. So we got just in a summary, just in a nutshell, what are now the benefits to laboratory staff? Why is analysis important in our day-to-day activity? Why do we need to analyze our data, so that we don't blame other cadres, that the PHOs, they come, collect our data, and they use it for other means, something of that sort? Why do you analyze our data? Why is our data important? Why should we monitor the trend? So one is a proactive problem detection. It usually it can catch issues before they become major problems affecting the patient care. So you can actually detect it. You can actually detect these earlier before it blows out of proportion. So you are able, it becomes as a step measure that you can actually come up with that, and you can detect it when there's still time, and you correct it. So in terms of the analysis, it also improves the efficiency. It optimizes workflows. It reduces repeat testing, and it helps us to manage resources, because we'll not be wasting resources. Then we've also got enhanced credibility. It provides data-driven evidence for the laboratory performance and improvement needs. There's after you've identified the gap, maybe you are doing data quality assessment in your facility. You're able to come up with the gap, then you will be able to address the gap. Maybe by doing what we call data quality, or you are doing data review before submission. You are able to come up with the gaps. That are these figures that I sent maybe to the HRO, or the figures that were logged in the KHIS, are they ours? Are we able to own up the data? The issue here is ownership. Are we able to own up our data? So that if your data are visualized, you will own up that this is really our work. Then the professional development, it builds analytical skills that enhance career advancement opportunities. I've talked about coming up with abstracts. We can do publications, we can do manuscripts, and we can do all sorts of issues when it comes to data. Then better patient outcomes. The hallmark of doing the descriptive analysis is to improve the patient care, to contribute directly to improved healthcare through systematic data analysis. So the parting shot today, I would urge our members that kindly let's embrace data utilization. Let us own our data so that we can actually improve on so many things. Let's not cry foul that somebody is utilizing our data or we are handing over our data to partners to analyze them for us. And this is something that we can actually do. Yeah, we just do it small. It's just a matter of just you can do it. You can do it in terms of tables, graphs, what so many things. So that is the end of my presentation, and allow me to appreciate the Lab Medicine Society of Kenya for giving me the opportunity to talk to you. And I also like to thank my county government, that is Kisumu County, and more so where I'm now placed, that is National Malaria Control Program, and where my training was, that is the field epidemiology and laboratory training, that is FELTEP, and above all, the Ministry of Health for the opportunity. And I'd like to take the opportunity to thank you so much for listening to me, but this is not the end. I just basically did a descriptive bit of it. I've just done descriptive, which is just summary. Maybe given opportunity, I'll take you through what we call the analytical bit of it so that we get to know how do we interpret the p-values, 95% confidence intervals, 98% confidence, 99% confidence intervals. How do we calculate the odds ratio? How do we calculate the risk ratios? How do we interpret the p-values of 0.01, 0.02, 0.03? How do we use the frequencies and proportions in our day-to-day analysis of the laboratory data? Otherwise, back to you, Arthur. Thank you so much for listening to me, Tim.
Thanks so much. Thanks so much, Mr. Duncan, for this wonderful and insightful presentation. Without maybe further ado, allow me to check on the Q&A section and share with you the type of questions that we've received. So we have quite a number of questions. Probably allow me to start with a question from Benson Lucenaka, and it goes, is it possible that you can use either descriptive or analytical for data analysis alone? Back to you, Duncan.
Thank you so much, Ben, for that wonderful question. So yes, you can use both descriptive and analytical, but analytical analysis is usually used when you want to compare. There's a comparison group. You want to compare the association between two groups. I talked about cigarette smoking and lung cancer. We've got a control and a case. So when you use analytical, you'd be comparing like what is the odds or what is the risk of one contracting lung cancer without smoking? Or what is the relationship between smoking and developing lung cancer? Thank you, and back to you.
Yeah, thank you for that response. Allow me to read our second question from Charles Yator, and it goes, just highlight the importance of having a legend in tables and figures. Back to you.
So thank you so much, Charles. So statistically, the legends are also very important, depending on what kind of graph you'd want to you want to visualize. It depends with the kind of graph that you maybe want to visualize. But I'd say that the grid lines, the data labels, and the size of the graphs, you need to work on them if you want your graph to be very much presentable. But the legends, it depends with the kind of graph that maybe you want to share or what you want to present. Thank you, and back over.
Yeah, thank you. Alfred Ojuaka has a question. It goes, how can a small lab with limited capacity and knowledge on statistical software analyze their data and come up with alerts and action threshold? Back to you.
So thank you so much, Albert. Albert is from Chulaimbo. Thank you so much for that wonderful question. So I tend to believe majority of our places, and we've got the data, and the alert and threshold, or alert and threshold outputs. They're usually calculated. It is usually historic 5-year period historic data. And if you want to calculate it manually, you're supposed to get the mean data, that is the mean of all the data sets, that is 9. Then you get the standard deviation of them. You get the standard deviation from the mean, the 9 mean. You add it to plus 1.5 standard deviation. Then from that, you are able to get what you call now the alert and the threshold. But depending on what the facilities has been the data that they've been generating, the malaria data that they've been generating, or maybe the typhoid data, or the measles data that they've been generating for the past 5 years, is usually a historic data. But you can reach me privately so that I can take you through how to plot alert and threshold manually. But nowadays, it's usually calculated automatically in our KHIS. Thank you, and over.
Yeah, thank you. Thank you for that response. Another question from Yona Chetamba Kutete, and it goes, how can we use the generated data in our workplaces to help inform workload distribution and workflow efficiency? Back to you.
Thank you so much, Yona. I'd say that. So this one is very easy. How do we use the data that you've generated in our places or workplaces? It's very easy. You can either use the descriptive or analytical methods or the softwares. Nowadays, with the AI on board and everything on board, you only need your data, and you analyze it. After the analysis, you come up with a conclusion and conclusion, and you discuss it. Then you visualize it very well. But you cannot usually start with the advanced Excel or just the normal Excel, so that you come up with just the tables. You come up with the graphs. You come up with the pie charts. Just as simple as that, depending on what. Because most of the statistical softwares like the Stata, the SPSS, and the rest, some are usually bought. And maybe you cannot afford that. So use what you have in place. You start small as you develop pole pole. Thank you.
Yeah, thank you. Another question from one of my lecturers, Dr. Tom Were, and it goes, what about postgraduate, undergraduate students collecting secondary data and using it to write theses without research permits or ethical approval? Back to you.
Thank you so much, Dr. Were, for that. And I think that is what we call a theft, is educational theft. So why do you use why do you write your thesis without approval? It's got to be approved, the secondary data that you are using, because what I've seen in most of the places, that the secondary data that you are collecting as undergraduate, it must pass IREC somewhere for it to be validated, for you to proceed. So that, because you've also got to do the plagiarism check, that whatever you are doing, it has not been done somewhere else, and it is your own data. So you've got to own up your work. Matter of just ownership. Otherwise, if it's not that, then that is theft, academic theft, plagiarism. Thank you, and over.
Yeah, thank you. We have quite a number of questions from Alfred Ojuaka, and allow me combine all the questions, so maybe you can tackle all the questions from Alfred at once. So the first question is, are there instances where skewed data is considered normal? That's the first question. The second question is, are there recommended periods between baseline, midline, and endline assessment? That's question 2. Then question 3, kindly elaborate on how to track precision and accuracy metrics over time. And then lastly, how do you go about data discordance, for instance, between KHIS and EMR? Back to you.
Thank you so much, Alfred, for those wonderful questions. Let me start with how to track or how to do the data the data discordance. So I talked about in the data discordance, you do what we call data quality audit, and you do what we call cross check. If you do the cross check between 204A, 204B, 705A and B, and 240. 240B, which is the laboratory register, and use the 505 data and KHIS, you're supposed to come up with what we call the verification factor. So the verification factor is supposed to calculate for you. I'd said 0.9, that is 90% and below, is over-reporting, while over 1.1 of the data is under-reporting. So you are able to track that. You just get the sources from your data sources. Get the data from the primary sources, compare them, come up with a verification factor. If you are not able to calculate the verification factor, Alfred, you can reach out to me. I'll take you through how to calculate the verification factor so that you get to know, was there discordance or was there concordance? So the word here is concurrence. Was there concurrence between across the reporting, that is the malaria reporting tools? Coming to the skewedness, I said there's a way you can actually troubleshoot, or you can come up with you can work on the outliers. So in terms of the outliers, I'd said the 3 reasons how you can work on that. You can either use stratification, you can use randomization or stratification, so that you work on the outliers that you've talked about, the skewed data. And on the skewed data, I talked about the rule of thumb. Rule of thumb while using measures of central tendency. If my mean is 2 times the standard deviation, then I'll not use the mean and the standard deviation. I'll go straight to median and interquartile range. If my mean and standard deviation are okay, then I'll use mean and standard deviation in my deduction. Then I got there were so many. The second question, I don't know, was about how to record the data. What was the second question? The second question was how to record, how to detect.
Have you answered about the recommended period between baseline?
I've talked about the data discordance, and I've talked about the first question. I've answered him. The first question instances.
Are you able to? He wants you to elaborate how to track precision and accuracy.
Or how to track accuracy. Oh, you talked about accurate and precision
and accuracy metrics over time. Yes.
Yeah. The in laboratory, what is usually there? We've got Westgard software in place, just to track for us the accuracy and the precision in place. So you just feed the data in the WestGuard, and we've got the WestGuard rules that one's supposed to use while tracking the precision and the accuracy in the laboratory. So this one, you can use the WestGuard software to tackle that.
Thank you.
Thank you. And over.
Thank you. Let's look at our last question from Nelly Ogada, and it goes, how do you handle issues of ethics, such as consenting the patients for use of their samples or data, especially when you get to publishing the data?
Thank you so much, Ogada, for that wonderful question. So we've got what we call, that's why we are really championing for ethical review. So once your protocol, let me talk of the protocol. The protocol down the bit at the tail end of the conclusion bit of a protocol, you're supposed to come up with what we call the ethical as your study that you've done or you are intending to do has got ethical approval. So you are supposed to do, you have ethical approval and NACOST permit. You are supposed to have NACOST permit and ethical permit. And by the time you are consenting the clients, we've got assenting and consenting. So they've got to sign. Your clients are supposed to sign. And they should have read and should have actually taken them through your consent. That, I'll be taking this sample and this sample I'll use this and this and this, so that they attest to it that they've read and understood this. You don't just do it just like that. So we must have ethical approval from any IREC body, maybe JTRH, MOI, any IREC bodies are many. Then you've also got to have what we call the NACOST permit for you. Then you are supposed to have assenting for the minors and consent forms for the adults. Assenting form for minors and consent forms for the minors. And they've got to sign, they've got to attest. In assent form, maybe the guardian or the parent can assent on their behalf. Thank you, and over.
Thank you very much, Mr. Duncan, for this wonderful presentation. We've come to the end of today's webinar, and therefore, allow me to bring you back, Mr. Duncan, to give you a parting shot before I conclude. Welcome again.
Thank you so much, Health and Laboratory Medicine, for giving me the opportunity. And let me also take this opportunity to thank all our listeners, those of us who joined and listened to us. And let's put it upon us, and let it be our culture that data analysis, let it be part of us. Let's always start small, and let's not blame someone that someone is actually coming for our data, yet as we are currently doing nothing about that. So let's start small so that we can come up with publications, we can come up with manuscripts, we can come up with abstracts, and we can do a lot of publication on that. I'm very much free for consultation, but given time next time, maybe I'll take them through analytical bit of it, which is very much interesting if you'll give me the opportunity next time. Thank you, and have a lovely evening to you too.
Thank you, Mr. Duncan. We've really appreciated your efforts to bring us this topic today, and I believe a number of participants have learned a lot today. To our participants, we are grateful that you managed to join us today, and we also welcome you again to be part of this journey on Friday as we bring on board another quite interesting presentation that we'll be having on Friday. Otherwise, from our Lab Medicine Society of Kenya, we thank you, and we want to wish you a good.
Thank you so much.